Optimization for multi-channel machines allow you to optimize NC code that runs on selected channels, or all channels at once. In Vericut 9.1, optimization has been improved with faster, easier analysis and optimization setup with new Force Learn mode and Force Charts enhancements. Learn mode introduces artificial intelligence for optimization. Vericut learns from cutting while you simulate, automatically sets up tools for optimizing, and can auto-optimize the NC programs after learning. Using Learn mode, almost anyone can create highly optimized NC programs from existing programs that already run in the shop. Vericut 9.1 includes more robust support for tools arranged on multi-tool stations, including support for tap tools and dead non-spinning drills. Vericut provides error notifications for motions that are not along the tool's axis, such as lateral tool motions, and when tap feed rates and spindle RPM will not produce the desired threads. In Vericut 9.1, users have the ability to capture informative images with clear instructions that describe the setup plan for the machine. Annotated images clarify what the machine setup should be and what to expect when running the part program to ensure the finished part matches the intended design. Create inspection plans with dimensions, notes, and tolerances for checking parts at various stages of machining. Mill and hole making tools in Vericut 9.1 have greater control over describing the non-cutting shank portion of a tool assembly. Defining shanks as separate objects from the holder and the cutter enables programmers to see where the non-cutting portions of the tool are relative to the stock workpiece and allows more discrete control over near-miss and collision detection properties and tolerances. In Vericut 9.1, users have the ability to simulate additive manufacturing processes without the need for a starting stock model. Build nested additive parts and assemble them into bonded parts, or move them independently into subsequent setups for machining. A new additive default machining type enables Vericut to make the best use of system resources to improve additive simulation performance, which is especially helpful for big area additive manufacturing and large-scale additive manufacturing parts. In Vericut 9.1, users have the ability to quickly see unobstructed views of the cutting process and gain better access to the part by removing objects with invisible and disable actions. Invisible hides objects, components, or models from view, but they still exist in the simulation for collision detection. Disabled omits the object from simulation by hiding it from view and ignoring it for collision detection.